Hi there. My name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are studying quadratic relations. It is the quadratic relations unit of the course. That's pretty obvious. Thanks, Miss. It's looking at word problems, in particular word problems in which no equation is given to you, so you have to figure out the equation based on the information. So based on a word problem homework sheet, this is going to be the solution to question number 11. Let's have a look. Two numbers differ by 6. If the numbers are squared and then added, the result is 146. What are the numbers? So hopefully a fairly straightforward question here. Obviously, it wants to know what the numbers are, so let's define x and y to be the numbers. Let x be one number, let y be the other. Oh, let y, I've made too many videos today and my brain is melting. Anyway, let y be the other. Okay, now we need to create equations. One equation is about the relationship between x and y, and here's the relationship right here. They differ by 6. There's a whole bunch of ways to say that algebraically. Here's one way, that the difference between them is 6, or I could have picked x to be smaller. I could also say that if I add 6 to x, I get y, or I could say that if I subtract 6 from x, I get y, or I could do y plus 6 equals x, or one more method, I could also say that y minus 6 equals x. All of these say that x and y differ by 6. So we need to pick one of these to include in our actual form of solution. Now, we know that we're eventually going to be doing a substitution, and therefore we should pick one of these explicitly written equations instead of one of these implicit relations. Boy, I'm using some vocabulary on you guys today. An explicit equation is an equation in which one variable is isolated, meaning that it's very clear to me when I look at this equation, it's very clear exactly how to find y if I know what x is. I take x, I add 6, boom, there's y. That's called an explicit equation. Here's another example of an explicit equation. It's explicitly written in terms of x, and that means that I can solve x exactly by doing the following things to y. Take y, subtract 6, boom, there's my answer. Whereas up here, I have to do a little bit of algebra to figure out what x is knowing y, or what y is knowing x. So I'm going to take, oh, what the heck, let's take this equation. We're going to say that y equals x plus 6. So there's the relationship. And again, it still says that the two numbers differ by 6. So there's my first equation showing the relationship between x and y. Now I have to create an equation out of this sentence. If the numbers are squared and then added, the result is 146. So if I take the numbers and square them, and then I add them together, I get 146. So this is where my quadratic equation is going to show up. And now I can do that substitution. And because I picked an explicitly written equation, it's going to be very easy to do that substitution. I know that instead of y, I can write x plus 6. So now I have one equation with a single unknown called x, and I can go ahead and do algebra to solve. Oops, that line shouldn't be there. So let's do FOIL, or expand that bracket. So square the first, double the product, square the last. So now I'm going to collect like terms and make it equal to 0. So I have 2x squared plus 12x. 36 minus 146, that's minus 110. And now let's solve. So again, I could use a quadratic equation, but I've used that an awful lot. So I'm going to solve this one by factoring. So I'm going to common factor out that 2. And inside of this bracket, I have a simple trinomial. So are there two numbers that multiply to negative 55 and add to 6? Yep, positive 11 and negative 5. So now that I have those numbers, I've factored this equation. And because it's equal to 0, I can now use the 0 principle. I have three things multiplied together. If any of those three things was 0, the other two things are irrelevant because 0 times anything is 0. So let's see if we can make these three things 0. Well, it's impossible to make 2 into 0 because 2 is a different number. So we can skip that. But this first bracket that I see, x plus 11, we can make that into 0 if we let x equal negative 11. So that's one of my roots or one of my solutions for x. Boy, I'm really slanted all of a sudden. Or if I take this other bracket, oh, that's better, then I can solve for it. And I know that if x equals 5, I have a 0 here. So there's my two roots. X is negative 11 and x is 5. Let's go ahead and see if they both make sense. Let x be one number, let y be the other. Well, they're supposed to be numbers, and both negative 11 and positive 5 are numbers. Let's figure out what y has to be. If x is negative 11, what would y have to be? Well, again, here's my relationship between x and y. If I take x and add 6, I have y. So if x is negative 11, then y is negative 5. Over here, if x is 5, y is 11. Do both of these pairs of answers satisfy the conditions? Well, they both differ by 6. If I square them and add them, do they result in 146? Well, let's check. Is it true that negative 11 squared plus negative 5 squared equals 146? Let's check. Yes, that pair of numbers works. If I used positive 5 and positive 11, obviously it would still work. So in fact, there's two answers to this question. The numbers are 5 and 11, or negative 5 and negative 11. So make sure you understand why I say that there are two answers, not four. One answer is this set of numbers, and the other answer is this set of numbers, and both of them satisfy the question. Okay, thanks for watching this video. I'll see you around.